Hi, I'm an old guy and I do maths. Today we're going to explore rational root theorem, and our instruction is to use rational root theorem to find a solution to this cubic. Here's the cubic. Function of x equals 2x cubed minus 3x squared plus 8x plus 5. And what we're looking for is we're looking for a solution, or, if we get carried away, maybe a series of solutions that will give us this answer, 0 for x. Right, so what's involved? Now, generally speaking, if you're confronted with something like this and you're not told to use rational root theorem, the first thing you would do is you would try putting 1 into this, and then you'd try -1. And if that didn't work, you'd go up to 2 and -2, -3, did I say +3? I didn't, maybe. If you got really carried away, you might go up to 5 or 6, at which point you might be feeling a bit exhausted and dejected. Now, rational root theorem is a way around this. And it doesn't mean that you don't have to use factor theorem to start with. We've been told to use rational root theorem here. Sometimes you can just look at the thing and go, oh, well, 1 will give me 0 and it's all over. You don't have to do anything more. Rational root theorem works really well when you've rejected a whole pile of others. So let's just see how we do with this and what we do. Okay, so what we do is we take note of this coefficient here and this number here, the constant, and we factorize them. And if we take the factors of 5, we get 1 and 5. And if we take the factors of 2, we get 1 and 2. And then what we do is we combine them in as many permutations as we can get in the negative. So if this were -5, we would have -1, +1, -5, +5. We're just going to assume that all the factors here are positive for this and for this, and let's go to work. So what do we do? Well, here's exactly what we do. We make up a list of possible solutions. And here goes. So we'll start with these two here. So -1 over 1, which is we make a negative of that divided by that. The next one is -1 over 2. Again, we make a negative version of that over that. And that kind of exhausts our 1s and 2s. So we move on to the 5. So -5 over 1. I'll write it in here, but it's just -5. And then -5 over 2. Now, what do you do from here? Well, the assumption is that you've already tried 1 and -1. So we'll just write that one off. And if you're particularly daring, you might have got up to, say, -5 and +5. So we're going to write that one off too. As I say, when you're confronted with something like this, you might just go straight to factor theorem and maybe get up to about 4 or 5, and then resort to rational root theorem, which means that this is a good starting candidate. So what we're saying is that is a good starting candidate for factorizing this and finding a solution for 0. So where do we go from here? Well, what we do is this is a potential solution. So this is a potential factor. Now, you're probably more used to going from here to here. So let's just explain how I got from here to here. And it's easier if I work on this. So if I say that 2x plus 1 equals 0, then 2x is going to equal -1, and x is going to equal -1 over 2. That's how I would get from there to there. Now, reverse engineering this, I simply multiply x by 2, and I'll do that. I get 2x equals -1, subtract, add 1 to both sides, and I get 2x plus 1 equals 0. I'm back where I started. So that's how we get from there to there. As I say, normally you're used to getting from there to there. Now let's just see if this works. Now how do we see if this works? Well, in a really traditional method. 2x plus 1 divided by 2x cubed minus 3x squared plus 8x plus 5. Now, if we get a remainder of 0 for this, we know that this is a factor and that therefore that is a solution. Now, we were asked to find a solution, so that will do us. If you wanted to find all the solutions, whatever we get up here, as a result of dividing this by this, should be able to be factorized. It's possible that it won't have a solution for x, in which case, if you were drawing the cubic, for instance, it might look like that. That being the solution we found, and it may just be that there are no other solutions for x. Anyway, we're tasked with finding a solution. So, fingers crossed, we'll check this. So, what do I do to 2x to get 2x cubed? Well, I multiply it by x squared, and that gives me 2x cubed plus x squared. I subtract this from that, so that is -3x squared minus x squared, which gives me -4x squared. By the way, that minus that is nothing. It simply goes away. So to just make this completely obvious, this all gets subtracted from here. And what I'm left with is -4x squared. I bring down the 8x from here, and I say to myself, either quietly in my head, or if I'm alone, I may say it out loud, what do I have to do to 2x to get -4x squared? And the answer is multiply it by -2x. So that gives me -4x squared, and that gives me -2x minus 2x. And again, I go through the subtraction, these disappear. Positive 8x minus -2x gives me 10x, and I bring down the 5. What do I do to 2x to get 10x? Well, I multiply it by 5, and I get 10x plus 1 times 5, 5. Do the subtraction, and the answer is 0. Now, technically, we have answered the question. We have found, because this remainder is 0, we have found a factor and a solution. for this cubic. Now, I won't go any further, but if you wanted to see if there are other factors, minus 2x plus 5, which is what we get up here, you would take this and you would either try to factorize it. It's not going to factorize easily. You're going to have to try and complete the square or use the quadratic formula. The first thing I would check is I'd check the part of the quadratic formula, this little part, and as I've gone this far, I might as well do it to see if there is actually a real solution for this. So b squared is 4, negative 2 squared. That's 4. We're looking for the square root of 4 minus 4 times 1 times 5. And what we get for our trouble is 4 minus 20, which is negative 16. Now, this is all an aside to what we've been doing. This tells us that there is no real solution for this quadratic here, which means that not at all that the graph doesn't exist. It simply means that this part of the graph does not touch the x-axis. There is only one factor and therefore only one solution, which is x equals negative a half. And we got there through rational root theorem. Now, if this had proved unsuccessful, this would have been our next shot. And you can see that that's probably a less attractive job than this. So, big tick there, we can cross that one off. We have just one solution for this cubic, and that's it. There. Thanks very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.